Okay, so obviously you need to know how to solve systems of equations by hand because they will be on the no calculator portion of the test too. But you will likely see them on the calculator portion. Um, on the calculator portion, they tend to be like this, the second example that we're going to do here today. I'm going to go back over the first one because if you were given this question right here, again, strategy-wise, scan the answer choices. Here you see, you know you have solutions. What I can see is that y is 2 for most of them and then -2 for the other one. Like ideally, like I would probably just plug in these answer choices first. So like if I look at the y being 2, so I would take this top equation here and I would test 2x minus 2 equals 6. So is x going to be one of these three? Okay, because it can't be all of them, right? That's the idea here is that x, you might get an x and a y where it's 2, but they can't all be the same. In fact, only one of them can work. So if I test a y of 2 as my first number to test, I'm going to eliminate at least 2 of these choices. So when I plug in a 2 up here, I get 2 times a -2 is -4 minus 2. That's not it. I get 2 times a -6 is -12 minus 2. That's not it. And then down here, 4 times 2 is 8 minus 2 is 6. So this one works for the top equation. So let me go ahead then and plug it in for the bottom one. 4 plus 2 times 2, does that equal -2? It does not. And so just by testing the one thing, knowing I'm going to eliminate at least 2 of them, I wind up eliminating all three, which means the only solution left is this one. And I can test that. If I plug it into both of those options, or both of those equations, it's going to confirm each one. So that would be, again, that's probably the first strategy I would use. Now, since you can use a TID9 on the SAT, it's not a bad idea to know how the system solver works. So we talked about it last time, but let's review it. Hey, you first need to go into the custom tabs. The custom tabs have a solve tab up here. So notice there's no solve tab on the display. So if I hit second home, where it says this blue custom, this accesses the custom tabs, and now my F3 tab is solve. And this final, this line 4 right here is the system solving template. So do make sure that your cursor is this insert cursor. Okay, if you hit second and backspace, notice that cursor now changes to a block cursor. Now it's going to overwrite everything, and for a lot of times, students accidentally hit that sometime along the way, and they don't know how to get back from it. But it's second backspace toggles back and forth between the insert and delete. So make sure it's in the insert mode with the little cursor. And if you put this in front of the and just type your equation, 2x minus y equals 6, scroll after the and, type in the next equation, x plus 2y equals -2. Make sure any negative signs in front of numbers, use the change of sign key here, not the subtraction key. And once you type in both and you get your answer, you can see it confirms 2 and -2 is the solution. Right, so you can use the system solving template anytime you have a system with the calculator portion. Now, more than likely, this next question right here, 14, this is like the type of question that will likely show up on there. So what I want you to do is see how you would solve this on your own first. I'll talk through the strategy of it, but it's pretty consistent with a type of question that SAT tends to give students. So I'm going to show you that you can solve this with the system solving template. It's not the most efficient, and I'll come back and show you what I would recommend. But if you use the system solving template for this, you could still get the right answer, right? Just to review how to do it again, access the solve command, type in the equation, and the second equation. And this is going to give you values for your x and y. And so now if it did ask you, like it does in this question, what's the value of 3x plus y. Well, the x was 4 and the y was 3, so you get 12 plus 3, which is 15. And so you can solve it this way. It's not the most efficient way, but it can be done, and it can be done with a pretty high level of certainty that you got it right. Okay. The method that you will likely use for the calculator portion, and it's especially true when they ask you to solve for an expression and not just a variable x or y, and that is oftentimes you can directly combine your equations to get this form. And so if it asks you what's the value of 3x plus y, look at the two equations and see, is there some way to directly add them or subtract them to get that form? Well, if we just combine straight down the column of like terms here, x plus 2x is 3x, 2y minus y is a plus y, 10 plus 5 is a 15. Notice 3x plus y is right here. It's a direct solution. It tells you exactly what it's equal to. SATs have been doing this type of question for decades. And so this is a very common type of question that's pretty unique to SATs. ACTs won't give you a problem like this. All right. Go ahead and try the next one. Again, it's a slightly different type of question. It does require you to know a little bit about the alternatives to when a system of equation does not have a solution, or it has many solutions. There's three options for that, right? No solution, one solution, or an infinitely many solutions. So see if you recall and work with that on this problem. All right, so for this one, again, you can use your calculator if you want to. Okay, but for this one, I'm just going to talk through. If you were solving this by linear combination, you need to cancel either your x's or your y's. So here, since the y's are, or actually they're both opposite of each other, so if we look to cancel our x's, we need to multiply the top equation by a number so that we get the exact opposite of the coefficient of x. So if we multiply 5x by 12, we get 60x, and if we distribute that to each, we get a minus 12y and a minus 108. And now we combine these columns straight down of like terms. 0 plus 0 equals 0. All right, so one of three things is going to happen here. Either you're going to solve for y and get a one solution. Okay? You're going to get this statement right here where 0 is equal to 0. Since this is a true statement, that means that there's infinitely many solutions. If you happen to get some number where 0 is equal to some other number other than 0, then that means that there would be no solutions or 0 solutions. And so that's the different possibilities, right? If you get or y equals a number, there's 1. If you get 0 equals 0, then it's true for all numbers, so infinitely many. And if you get 0 equals some non-zero number, then it's no solution. Okay, so this one here was just the infinitely many. All right, one last question here. We'll jump again. We'll tend to focus on the odd problems with an occasional even. Okay, but I want you to try question 17 here. See if you can solve this, please. How many of you worked with fractions and tried to combine t's? Did anybody try to solve for t? Okay, so that makes it a little more complicated. Again, you can get the answer that way. You can get the answer by using the solve feature, the system solver on your calculator, but also like is a little bit more complicated. But if you simplify, again, most of the time the SAT is set up in a way that you can solve questions with relatively basic calculations. So notice here, and I'm gonna talk about it one way, but you don't necessarily have to see it that way. But if I look at this and say 1/3 t plus 5, let me call that x, and I'm going to call 1/2 t minus 4y. So if I were to do that, then this equation right here, I could rewrite it as what? X plus y equals 37. And what could I rewrite my second equation as? X minus y equals 19. If I gave you that, would you be able to solve for x and y? Yeah, it's easier in that way, right? So if you can kind of look to see, like, can you represent this in a much easier, more straightforward way? Look to see if you can do that. Because now if I combine straight down my columns, I get 2x, the y's cancel, is equal to 56, divide by 2. I get x is equal to 2 goes into 5 twice with 1 remaining, 2 goes into 16 8 times. So my x value is 28. And my y value, if I just come in and I plug this into either of these forms, right, it doesn't matter which one. So let's say I take this top equation right here, and I say 28 plus y is equal to 37. My corresponding y is going to be 37 minus 28, which is 9. And so there's my answer, 28 times 9. And if I actually multiply those out, I get 9 times 20 is 180, 9 times 8 is 72, so 180 plus 72 is 252. And so that would be my answer. And I can get it again a little more direct way, but look for direct combinations on these. You shouldn't really have to work with fractions too much unless the fractions are really easy to work with. Okay, so once you catch yourself trying, like, you should not have to combine 1/3 t plus or minus 1/2 t and try to like reevaluate those. The SAT is not really designed to be set up that way. All right. If we jump to the next page here, page 8. Oops. Okay, try this first one. Again, we're going back to some of the same strategies from the calculator, or the no calculator portion, are also very common in the calculator. The main strategy was solving systems of equations. That's going to be the most likely thing that you see on the calculator portion. Okay, but also, as far as the Algebra 1 concepts, the next most common thing is taking a linear model and interpreting that. So there's a couple main ways that this question will tend to be solved. So mathematically speaking, this question is intended to be solved by creating your own system of equations and then solving it. And so if that's what you were doing here, again, scan the answer choices, see what you have. They're just numbers, so there's nothing distinct about it. So if we read the problem, last week Raul worked 11 more hours than Angelica. So this means that R equals A plus 11, right? That would be a way to model that information. And then if they worked a combined total of 59 hours, that means that R plus A added together is 59. So here is my system of equations. I would solve this probably, since we're looking to solve for A here, I would probably just use substitution. A plus 11 can be substituted in for this R, plus A is equal to 59. Combine what I have, 2A, subtract 11 from both sides, is equal to 48. Divide, I get A is equal to 24, and there is my answer. So that's the mathematical way that they've kind of set up to solve this. Now, more than likely, I wouldn't solve it this mathematical way. What I would probably look to see is, when I scan the answer choices, I see that all my answers are numbers. Okay, and so I know that one of these is the value for A. Okay, so one of these is A. Well, if Raul worked 11 more hours than Angelica, then that means that he worked here. If I just took 11 plus 24 is 35, 11 plus 35 is 46, 11 plus 37 is 48, and 11 plus 48 is 59. So if I looked, what I would do is I would just test these scenarios, and I know that my total has to be 59. And so when I look through these, there's only one of these combinations that's equal to 59, and that is this one. And so I know that my A value has to be 24. So you can plug numbers in, and again, it's a matter of kind of getting familiar, doing as many of the tests that you can find as possible, and that gives you sort of an idea of what type of questions they will ask, and it lends itself to figuring those patterns out. All right, since this next question is just really quick, and I want you to be able to answer quick questions quickly. Okay, so there's a difference between, you expect to see some questions that are easy. Okay, and so the idea on the SAT is that you can answer the easy questions really fast so you can spend more time on the more complex questions. Okay, so see if you can answer this question as quickly as possible and get it correct. Okay, when you scan the answer choices, you see the linear form, right? You see that this has an intercept and a slope, so our rate of change. And so you should be able to identify what each of those is. So like this would be started at 222 and you add 8 words per minute. So you can already interpret what the answers are even before looking at the question. Okay, and so what you need to see is what was the original words per minute, and then what's the rate of change? Well, we see that the rate of change is 8. You're either increasing or decreasing by 8 per month or per minute or each month. And so here you see it's increase. So you can eliminate C and D. You're not decreasing your value. So the only thing you need to identify is did this typist begin at 222 or did they begin at 184? And so even though you see 222 in it, this says that that's a requirement, but the person actually types 184 to start with. And so just be really careful. Don't just pick a number because you see it in there. Make sure you kind of search through and use the correct values for that. All right, same page, next question. This is a little bit harder question. So this one's getting a little bit more toward the end, as I mentioned to you. The SAT will tend to go easier questions first, harder questions come a little bit later in each section. When it jumps or when it skips to the fill-in, the grid-in questions, it resets. So the very first grid-in question is also going to be easy. And so skip around if you need to. Don't spend too much time on hard problems until the end, after you've already managed all of the questions that are easy for you. So go through the easy multiple choice questions, and then once it gets more challenging, jump to the easy grid-in questions, and then come back and answer any of the remaining ones. So this one is a little bit harder. However, you can still solve this question without a calculator just by using tendencies. Okay? So first step, always scan the answer choices. Okay, so I'm looking to see what's unique. So I obviously I'm seeing a linear function, right? It's the power of t is to the power of 1, so I know it's a linear form. And so I do see that the coefficient of my t, even though I'd have to expand this out to do it, but my coefficient of t is my rate of change. So I see that the rate of change is either -1/60 or it's 60. And those are going to give you like much different numbers. So I'm now going to go back in and I'm going to search through my problem to find points. Because I recognize that it's a linear equation, I'm going to find ordered pair. So I see that I have a gap width, which is our y value, right, the w, of 2.875 at 40. So one of my points is 40 and 2.875. And then my second point is 100 for the temperature, the input, and the 1.875 output. So those are the 2 points that I'm looking to test. Now, I have a couple different options that I can use. But what I notice is when I scan my answer choices that I see 40 in the problem already. So if I look at this problem right here, what I know is that when t is 40, my output has to be 2.875. So notice when I put in a 40 for my t here on each of these cases, when I get 40 minus 40, that's 0. 0 times anything is 0 plus 2.875. This actually works. So this, I have to consider this as a potential solution. But this one, 40 plus 40, does not cancel out here. It's not going to cancel and give me my 0. Here, 40 minus 40, I can consider my value here as well. And here, like 40, again, 40 plus 40 is 80 times 60. I know that that's not the case. Again, on this one, I have a negative number minus a number, so that's not the case. So I've limited this now down to 2 possibilities. Okay, and so I can test my second number, even without using a calculator, although you can use a calculator since this is the calculator portion. But if I plug in a 100 here and think which one is the reasonable answer, well, if I plug in, let me do a different color here. So if I plug in a 100 right here, 100 minus 40 is 60, 60 times 60 plus 2.875. Is there any way that that can become a 1.875? No, that's going to be way too big. So just by process of elimination, I didn't need a calculator to answer these and verify them, but I know that this is my only possible answer. And if I did plug in the 100 here, 100 minus 40 is 60. The 60s cancel, so I get negative 1 plus 2.875 is 1.875. So not only is it the last remaining one, but it's also, if I plug it in, it's the one that works mathematically. Okay. All right. These last 2 questions here in this section, question 23 and 24, these are questions that have only recently shown up. They showed up probably over the last 2 years after the COVID time. Okay, and so it's definitely something that they've been emphasizing. They show up more than what you would think. Okay, and so I did want to include some work with scatter plots. Or actually, it's not this one, sorry, the next question, not this one. But let's look at 23 first. Okay, so try this one on your own. It's on the next page, page 9. And see if you can interpret the graph here and find which of those equations is a line of best fit. We don't do a ton of work with regression equations here in the math department. Okay, but the idea is that if you plot points and then sketch a line of best fit, there's approximately the same number of points above the line as below the line and approximately the same distance from that line. So if you were to just kind of randomly, or not randomly, but kind of draw a line that maybe fits the condition, it's going to be somewhere like this. This isn't perfect, but this gives you a general sense. Okay, and so the idea on this is, let me go backwards, scan the answer choices. So what you see here is that you have this linear form, which makes sense because this is a scatter plot of a straight line, or represented by a straight line. So what you see is your slope, your rate of change is either 1.6 or 16, and your y-intercept is either a positive 15 or a negative 15. Now, you can't really tell from this graph what the intercepts are going to be, right? Because it cuts off at 90 and at 5, so you don't see where it actually passes through for the y-intercept. So that leaves a little bit more, like you can't rely on that to help gauge this. So what you're going to want to do is you're going to want to plug in some points. Okay, again, here's the way that the SAT works. Most of these questions, even in the calculator section, are ones that you should be able to solve without relying heavily on a calculator. So if I take the points, the values that you have points for, okay, and so what I mean is, like here's my very first point is at 5.2 and my very last point is at 6.8, right? So here's sort of the window of where I have points. What's the easiest number to plug in between those values? They're all decimals except for what? There's one integer. So you see that we can plug in 6. So my recommendation is just look to see, like you have this number that is easy to plug in. You can do it mentally because you don't need to know exact. All you need to know is that when I plug in a 6 for x, I should get a number somewhere in this range, right? Somewhere between what the actual value is versus and what the estimated value is. So somewhere between 110 or 108 and 112 should be my value, somewhere around there. So if I plug each of those in here, so negative 15.2 plus 1.6 times 6, is that going to be anywhere near the 100, like that 100 range? No, that's going to be way too small, right? So I can eliminate that. What about this one? 15.2 plus 1.6 times 6. Again, nowhere close to 110, 112, so that's not going to work. Negative 15.2 plus 16 times 6. Well, if I take 16 times 6, that is 96. 96 minus 15, does that give me anywhere near 110? No. And so my last one, 15.2 plus 16 times 6, does 96 plus 15.2 give me that range? Yeah. And so there's your answer. You don't have to actually know exactly what it is to understand that that's the only one that can possibly be the right choice. Okay. Process of elimination, as you can see, a number of these examples that I've gone through. Processes of elimination is one of the key strategies that you can use to maybe not solve it, but to at least eliminate answer choices that are not correct and give yourself a better chance to guess from the remaining ones. All right, again, it's an even one, but this is the problem where I was, and you'll see some, I think there's a couple more of these in the section on the data analysis and that where you're reading charts and graphs. Okay, but this is a type of question that they just started adding a couple years ago, and it's shown up a bunch of times. So again, I just want to make sure I talk about it so that you can see sort of what the trick they kind of use for this is sometimes. Because this is a question that you can answer quickly, but you might make a careless mistake if you're not careful in reading and interpreting what the words are asking you. Right. So in this kind of problem, what you need to be careful of is to determine, are they asking me to find the points above the line or below the line? Now, sometimes they'll use as a point of reference the line, and sometimes they'll use as a point of reference the points. And so they may ask you something for how many of these points is the projected cost above the actual cost. Well, if that's the case, then the line is above the points, right? We're looking for the points below. Okay, so it all has to do with how do they say above and below. So the question right here says, what's the number of computers for which the line of best fit predicts a value that's less than the actual value? So is this looking for points that are above the line or below the line? So the line of best fit is lower, which means we want the points that are above. Okay, so what we need to do is count the number of points that are above this line. So here I see 1, 2, 3, 4, 5, 6, 7, 8, 9. So the answer would be 9. Okay, now if it had said for what's the number of computers for which the actual value is less than the predicted, now you're looking at the points below. So again, you just need to be really careful and determine, are you looking for points above or points below? Use that as the reference so that you can count them. Don't base it on the word that they use, because they gave you the line here. Always use the points as your reference. All right. What I want to do here is we'll go ahead and start this next topic, or the next category. So all of those represented the main content, or the main topics that are covered in the Algebra 1 portion of those questions. Okay, so the next one here is going to be the topics that tend to be covered in the Algebra 2 type of topics. And the most common thing that's covered in this is nonlinear equations, and especially very heavily weighted exponential functions. exponential growth. And this is true for the newer one that's coming out next year as well. They also have exponential functions a lot. So let me talk really quickly, let me give you kind of a rundown really quickly of exponential growth versus exponential decay. Okay, the basic form for these is some a value where that's the original amount at time 0. Growth is going to take 1 plus some rate of change to the power of t. And so this number right here in the parentheses, this is going to be greater than 1. This is 1 plus some r value where r is the growth, the rate of change in decimal form. Decay is going to be that same initial amount, but this time you're going to take 1 minus that decimal rate of change, all to the power of t. Okay, so if this number here is less than 1, then it's decay. If it's greater than 1, you're talking growth. Okay, so based on that, I want you to see how would you interpret this problem? How would you solve this problem? Okay, so again, A is the original amount, or the amount at time 0. R is the percent change as a decimal, and that is either being added to 1 in growth or subtracted from 1 in decay. And then T is your time. Okay, so scan my answer choices. I see that I'm dealing with exponential growth or decay. And so it's just a matter of reading through. I know it's decay, so right away I can eliminate any number in the parentheses that's greater than 1. So I can eliminate A and B. Okay, there's a rate of change of 13%. So what that means is I'm going to take my original amount, which winds up being 388, times 1 minus 13% as a decimal, that's 0.13. So this is my actual amount, but it doesn't need to calculate the full thing to know 1 minus 0.13 is 87 or 0.87. So you can either eliminate that last one or you actually find the one that works, and answer choice D would be the correct answer. All right, once again, I'm not going to do like all of the evens, but occasionally there's ones that do highlight some things that show up quite a bit, and you'll see with the next few questions that using a fraction in the power of an exponential function is also something that has shown up a lot recently in the last couple of years. They tend to be emphasizing this, and as I mentioned, the new SAT versions that are coming out next year also do emphasize exponential functions. They show up quite a bit. So seeing how you would answer this question. And it does matter for you for the test that's being taken here this weekend. It matters where the question's located. Okay, this is a hard question. So this question right here is going to be missed by more students than get it right, I would imagine. So this is going to be like well toward the end. Okay, and that should give you a clue that it might not be the most obvious answer. Right? Because if it were a little more obvious, it would be earlier in the test. So if it comes at the later end of a test and it seems easy, there's probably like a trick that like fools most students or a lot of students. So for this one, that's the case. Be really careful because this would be located toward the much later section. This here should have been, sorry. That should be a t in the top there, sorry. So this is t over 3, or 1/3 t as your power. So if you come back to, and I'm just going to talk in general form here. When you look at what these powers of t represent that I just highlighted, in exponential growth, t means that's the amount of time it takes the growth factor to occur. So if you're saying that something doubles every however many years, that means that for a growth factor of 2 happens every t moments of time. And so when there's a fraction in front of that t, so like this right here represents 1/3 t, what that means is it's going to take 3 of those t values for that growth of 0.5% to happen. Okay? And so when you're looking at this, and it is always done in years, right? So when you're looking, this t is time here in years. So what this fraction, the 1/3 t right here, means that this growth factor is applied 3 times before, or it has to be applied 3 different years before you get to that 1 factor, right? That's what the division of 3 means. So that means that this is going to take 3 years to happen. Okay, now, here's where the trick comes into play. Okay, so hopefully, like, understanding that now, and you'll see on the next couple questions. Once you understand how the fraction works, it makes it really easy. So that growth of 0.5% is going to happen every 3 years. Okay, but the question's not asking you to answer in years. Okay, now, they give you the answer if you make that mistake. So if you're looking through this and you think, okay, well, the 1/3 means that the answer is 3. Okay, and you see that it might not be, it should ring a bell that, or a warning sign that, just like alarm that, hey, this might not be as easy as I think. Let me look carefully. Notice it says n is measured in months. Okay, so if you're dealing with 3 years, and 3 years is the correct answer, but how many months is that? And that would be 36 months. So just make sure that you're careful with answers, especially as they fall later in the section. If it seems too easy, double check it, look to see if there's something that's trying to be a little bit tricky in that. All right, if we go to the next page, see if you can use what I just said to help identify the answer for option or question 3. So this is on page 11, next page. So you should be able to see this pretty quickly. Okay, our answer choices, when we look and scan the answer choices, we see the original amount is either 200 or 150. Okay, and then the half-life, it's exponential decay, and the half-life happens, and you can see from here, this happens 150 times per year is what this power means, 200 times per year. And this is, it happens once every 200 years, happens once every 150 years. And so when you look here and see that it cuts in half with a half-life of 150 years, what that means is that there's only one option for that. Once you find this is going to occur 150 years for this to become half of what it started as. Okay? Again, if it's a multiplier in front of the t, it means it happens that many times in 1 year or per year. Okay, and so this is the only one, and the 200 is as the starting point, also confirmed there. So even if you didn't know that, you could at the very least reduce this down to a 50-50 chance of guessing right. All right, let's do this as a final problem, and then we'll break for the day. Okay, see if you can use, again, the same idea of what that fractional part of the exponential growth and decay means and how you would interpret it. Once again, if I come back up to explain, this happens 200 times per year, 150 times per year. And so the fractional part means that this is 1/200th time per year, which means that it's once every 200 years, right? So this is 1 over 150th. So it's 1/150th of a time per year. So that means that it's once every 150 years. So that's the same here, right? When you look at this, now we're doubling, right? The value, it's a growth factor, it's more than 1. So it's you start with 12, it's going to double, And here you see that that doubling happens t over 6. That means it happens 1/6 of a time every year. And so that means how many years will it take for it to double? Or sorry, now it's in days, and that would be 6. Okay, so whatever that rational or that denominator part is, that's going to be the number of time units it takes before that growth factor happens one time.